Thank you.
Good evening, everyone. My name is Lijing ZHU, and I'm now a PhD candidate of Professor Hua School, and I'm now working at the Advanced Networking Technology Lab. And today, the main contents of my presentation are reconfigurable optical architecture for HPC network and sharing of scientific research methods. This content is divided into 4 parts: an introduction to high-performance computing network and my method of searching for papers and reading papers, as well as some research tools. Now, I will briefly introduce my research work. First of all, we need to know what is HPC. And high-performance computing for HPC is an aggregation of computing power to solve problems which are either too large for standard computers or would take too long. And it's also referred to as supercomputing for this reason. And it enables the simulation or analysis of huge volumes of data that would otherwise not be possible with standard computers. The common challenge with high-performance computing is that we are producing or processing more data than our infrastructure resources can handle. And we have to wait for weeks or months to see the results, which typically delays the innovation and slows down our research. So we hope to improve the performance of HPC network. If we want to improve the performance of HPC network, we need to know exactly how HPC works. We can think of an HPC system as a group of computers called a cluster, and each computer in the cluster is called a node. Each unit in the cluster has an operating system, a processor with multi-cores, and storage and networking capability for the units to talk to each other. For example, the interconnect network, the protocol, and so on. And for example, there's a small clusters can have 16 nodes with 128 cores, which is 4 cores per processor, helping us solve the problem much faster. A supercomputer is much larger variation of this. An HPC job may need 3 months if it runs across on-premises cluster, but if it runs across 125,000 cores in the cloud, it will just need 16 hours with no incremental cost. So we know how the HPC works. What the key technologies will affect HPC performance? Our laboratory studies how to improve the performance of the HPC network from the following aspects. First, from the communication protocol, which communication between the nodes in an HPC network is necessary and important. They need to have a protocol, a certain protocol, or we can see as an agreement to ensure the accuracy or the accuracy or the correctness of the communication. However, these protocols in large-scale networks may affect the performance of the HPC and increase the communication delays. And by improving the communication protocol, lower latency and lower congestion of the HPC network can be obtained. And the second point is topology. Topology is a technology which interconnects nodes in a reasonable way. A good topology should be highly scalable to accommodate large-scale network. And now the architecture of an HPC network is a whole concept of communication methods and processes in the network. Each implementation method in the architecture will affect the performance of the HPC network. Therefore, we need to optimize implementation of the architecture to achieve higher performance and lower overhead HPC network. There are also some methods or techniques that can be used to improve HPC network, such as optimization techniques. We can improve the network performance by adding higher precision or more intelligent optimization methods to get a more adaptive or more intelligent network. We can also increase the integration density of the network and the communication bandwidth by adding silicon photonics, which is a new interconnection method. Silicon photonics-based networks are also the focus of our lab and my own research. Finally, by designing a switching mechanism or optical switching structure with better performance, the HPC network can achieve lower energy consumption and higher flexibility. Now that I have introduced some of the key technologies and new approaches to HPC, I will now introduce my own research focus. In the middle of these slides, as shown in Figure A, is an interconnection topology network, which is called Dragonfly, and which is a uniform and symmetrical network. And most interconnection networks are uniform structures like this one in HPC. And the other 5 graphs these 5 graphs represent the traffic patterns extracted from the different HPC applications. The X coordinate and the Y coordinate correspond to the serial number of the source group and the source group node and the destination group, respectively. Different color represent the communication demand traffic between communication pairs. It can be seen from these pictures. The communication pairs in the network are not evenly distributed. The brighter the color is, the higher the communication demand is, and the dark the color is, like this, like the black one. This means there's no traffic demand between these communication pairs. So we can see that the most HPC applications inject traffic on a few links or on a few communication pairs in the network. This leads to the mismatch between unbalanced traffic and even bandwidth allocation. Therefore, two properties can be concluded. Traffic within the network is sparse, and most links of the network are idle. So my main objective is to match unbalanced traffic with interconnection network by using the optic switch to design to achieve a reconfigurable interconnection network, and the co-designed effective routing algorithm for different HPC applications. After the introduction of my research work, I will share with you how to search for papers when I'm doing research. Oh, okay. The first thing we need to know is there's two popular index database. In the Web of Science, we can find journal papers, but there are no conference papers. So we need to search for top conference papers in the engineering village. These two are indexed databases, so there is only relevant information of the paper, but there's no full text of the paper. We need to go to the corresponding publisher to download the full text. And the searching method is simple and clear. We just need to input our keyword and click the search. And in general, the websites I use when I searching for papers are Google Scholar or the mirror sites of Google Scholar. When I need relevant information such as the impact factor or the number of this paper has been cited, I will go to the Web of Science to look up this kind of information. And this page, this slide lists some paper information that the Web of Science will display. I didn't list all here, and you can try to search some papers by yourself and see more informations. And if we want to download the papers we are interested in, these sites are the ones I use frequently, including the following full text database, for example, such as IEEE ACM and Elsevier and Springer. These websites require a university account to download it. If you are outside of school or cannot log in to your school account, you can search and download it on Science Hub, which is a convenient and free website for us. After we search for papers, we will find there are many papers we need to study. So we need to know how we read these papers. Before we read papers, we need to pick out papers that are highly relevant to us. First of all, we will have several keywords like HPC, reconfigurable network, and the optical interconnect, for example. And we will find many relevant papers, and each keyword will have a collection of related papers. What we want to read is the intersection parts of these keywords. We need to find highly relevant parts from these so many papers. From the title and the abstract, we can learn the research area and the key technologies this paper use. From the introduction, we can know the motivation and the problem this paper wants to solve. If the field you are searching for is relatively new, there may be a few papers in the intersection part. At this time, you can look at the intersection of any two keywords, which may give you some inspiration for your own solutions and your own research. And next, I will share my reading order. The left part of the slides lists the commonly used structures of technical papers, including the title, the abstract, introduction, and the new method, the introduction of new method, and the simulation results, and so on. And the first thing is to look at the title and the keyword and the abstract. After reading them, we need to decide whether to continue reading this paper or not. Then read the conclusion, see if this paper is our study interest. Just remember that we can stop reading this paper at any time. We also have to follow the laws of economics when we read papers. We don't want to try to salvage sunk cost and invest more time in the papers in papers that are no longer valuable or interesting. Next, we should look at the charts, the figures and tables in this paper if it has. At this stage, we should only look at the figures and annotations of figures. We do not read the context statements around it. Whether or not the figures catch your attention directly determines whether you want to take the next step, read the introduction. Because the main function of the introduction is to emphasize the value and the necessity of the research topic. It will try to connect the larger background and more important issues. However, figures that appear in the main part of the research can really tell us which direction this paper is actually oriented towards in the research area and how far it has advanced. After reading the figures and the introduction, we need to read the core part of the paper, which the new method and the results analysis part. Only when we think the paper is valuable, then we need to read this part. We need to read this part carefully from the beginning to the end, and the reading speed must be slowed down, and we may take more time on this part. And for some implementation steps and some experimental simulations, we even need to take the time to try to repeat it until we fully understand it. A lot of people think we are done after reading the papers, but I think this is not right. We've spent so much time reading the paper, so we need to save the time we've spent on it. The memory ability of our brain is actually far less reliable than we think. We need to take notes in time before we forget. We can write many things down. For example, the specific problem this paper wants to solve, the key innovation of the scheme proposed in the paper, and anything we concerned, the benchmark they use, the simulator they use, and maybe the simulation setup, and also the metric they use in their paper, and so on. And next time we want to read this paper, we just read the notes we wrote, which is more easy to understand. Okay, now I will share some scientific research tools. There are some document management tools, some applications that can help us manage our massive papers. For example, by using these papers, our papers can be grouped and categorized at multiple levels. Some can also add notes and set some text to the papers. These applications can also help us to add citations when we want to write in our own paper and or our technical reports. Each application has its own features, the advantages and disadvantages. So we need to find which one is the best for us, for ourselves. Which one is more suitable for ourselves. There are also some writing tools I want to share, which can help us checking our spelling, our grammar, and even improve our sentences, polish our sentences. These are very convenient research tools. This is applications, and they still have online website we can use. That's all my sharing. Thanks for your listening, and Happy New Year to you all. Thank you.
Thank you, Ms. Zhu. Thank you for your great sharing. It's a really useful topic, and you share with us how to search the papers that is quite useful for us, and how to read it, and to save the time. And especially, it's quite useful content especially for the new graduate student. Thank you so much. So, is there any questions from our audience? Any question?
I have a question.
Oh, sure, please.
You have mentioned something about HPC, so I want to know, how does the next generation of networking technology allow this high performance computing culture to connect with partners and clients faster, which is dramatically reduce the data transportation cost?
Sorry, I did. Sorry, can you repeat your problems?
Okay. How does
Sorry.
the next generation of networking technologies allow high performance computing culture to connect with other partners and clients faster, which is reduce the data transport costs?
Oh, so you want to know so how to make the HPC faster, right?
Well,
Yeah, in our laboratory, and the main content, the main research work is focused on the optical interconnect, which is more effective and low cost technology to use when we construct the HPC network. We think by using the optical switch on at the HPC network, the data transmission will become more quickly and more efficient. So this is our way to make the HPC more have better performance.
okay, got it. Thank you.
Okay, thank you.
Okay, thank you for your questions. Any other questions? Okay, thank you, Ms. Zhu again. Thank you for your great sharing. It's almost 3 hours, and I would like to say thank you for all your attention, especially most of you has been stay with us since beginning to now. So, ladies and gentlemen, I believe our forum is a great success now. It went smoothly as scheduled, and all the presentations and sharing were very illuminating and informative. So I like to give the sincere appreciation for all keynote speakers and sharing guests. Thank you. And also, I would like to thank all the participants for your attention to all the presentations, and thank you for your stimulating questions. So on the behalf of my colleague of the School of International Education of Xidian University, we wish you a very happy holiday and happy New Year, and hope we can meet each other again online after the Chinese New Year in some opportunity. Please pay attention on our further notice. Okay, thank you very much and have a good night.